concept we're talking about is solving systems of equations. Now, why are we solving systems of equations? Well, that's one of those things to where there are what I identified as 4 main standards to that concept. And they all kind of carry on to each other. So it's a, one feeds into the next, so to speak. You can't have 2 without 1. You can't have 3 without 2. So we have a metacognition taking place throughout the entire process of solving systems of equations. Here's the justification for a research methodology. We've seen a low performance on standards-based assessments within our own school, within our math department, especially as it pertains to higher order cognition. So they're doing just fine. The 4 times 6 equals 24 because they memorized that fact. But when they're asked to explain, how do you express 4 times 6 in terms of addition? There's a struggle there with students on that assessment. Also, the isolation of instructional techniques that encourage student struggle or promote teacher-led direction. So we can easily identify what techniques cause students to experience that struggle towards making connections. This also incorporates the problem and inquiry-based instruction, which is research-based. And also we have a comparison of quantitative data between intervention and non-intervention groups. So this is a quasi-experimental study. Also, we have the sampling of participants for the study itself. 2 classes. My 8th grade Algebra 1 class. That was 5th hour and 6th hour. They are comparable in size, an equal distribution between the 2 groups. 28, 29, 12 male, 16 female, 12 male, 17 female. Almost equal distribution among the ethnicities. And we have 1 student who is on accommodation for 504 for visual impairment. And I apologize, also comparable numbers for previous lunch. Now the key here is that there was 1 8th grade mathematics instructor for this. That was to eliminate any delineation between the 2 types of instruction. So I was that teacher. Our materials for the research question 1, we gathered baseline data through pre-instructional assessment, the post-instructional assessment, and also we had the control and intervention instruction. Systems of equations, problem and inquiry based for both, and I did use a timing device. And I'll explain that in just a moment. So for the baseline data, students were instructed at the very start of the unit on the basics for systems of equations. Simply put, how to read through a word problem, how to find the variables in the word problem, how to establish coefficients, set the equalities, basic operation of the system of equation, but without using the inquiry or problem base. So they got just a basic fundamental vignette, if you will, on solving systems of equations. From there, students were given a, where is it? Okay, so the assessment, the pre-instruction assessment. This was a common assessment between both the control and the experiment groups, or the intervention groups. And there were 4 standards that were scored based on the concept of systems of equations. We have the establishment of the equations and the variables, selection of the appropriate method, computation, execution, substitution within the system, and then solution to the system itself. Now, as I said a while ago, if you recall, you can't have 4 without 3, you can't have 3 without 2. You do not get a solution to the system without first having correct computation, execution, and substitution. This doesn't happen without having the selection of the appropriate method. And then, of course, that does not happen without having the establishment of the equations and variables. And what you'll see later on as we go through the data analysis, there's this thing called a diminishing return on this, which means that sometimes the scores will start out at the very first standard and then go downhill from there. And the reason being, if X amount of students miss standard 1, then those same students miss standard 2, plus the ones who got standard 1, who then miss standard 2 as well, and then down the line. So here's our instructional materials. This is an example of what the unit instruction will look like. And what we have here is 4 word problems. This is the kind of stuff, Mr. Bowling, that you like to refer to. The train leaves New York at 5:10 p.m. going 65 miles per hour towards Chicago. The train leaves Chicago at 6:20 p.m. going towards New York. Where do they meet? What time? Yeah, that kind of stuff. Stuff that kids like to do. And so for the control group, what we had was a method of direct instruction. This is me as the teacher going line by line. Students, this is what we're going to do. As a whole group, Look at number 1. Johnny, read number 1, and then Johnny reads number 1, and the entire class goes through it together at the pace of the instructor. What you see right here is the key that separates this type of instruction from what the intervention group experienced. Unlimited teacher response to student questions. Anytime the students, either individually or as a whole, had a question about the way a problem was solved, I would stop everything and tell them exactly what to do to solve the problem. So they could ask anything in the world about the problems and got no limit on the response from me. And it was almost immediate, it was instantaneous. And then there was no independent work. It was all done as a whole group. Now let's talk about the intervention group. The intervention group was given the same instructional materials as the control group. That's the problems that they solved. However, no instruction took place on how to solve systems of equations from word problems. Instead, they were given, I apologize for the small font on this. This is called the Modified Problem Solving Strategy, written by Watts 2015. So I take credit for this too. I might just patent this, Ms. Sherry, what do you think? We'll make a fortune on it.
I think you should.
Step 1 is understand the problem. There's 2 small bullet points next to that. Read the problem and restate it in your own words. Clearly identify what missing information you're being asked to find. At any point, a student had a question on these problems from the instructional materials, I would simply refer back to whatever step in the learned problem solving strategy that we've already discussed. So they got no information from me on no, this should be X and that should be Y. This should be your coefficient. That should be your, there was none of that stuff going on with the intervention group. It was refer to step 2 in your problem solving strategy. Students were also given a set amount of time, and most typically, as we went through the problems, essentially step by step with the problem solving strategy, 1 minute to 1.5 minutes per step. To have time to read the problem, identify their variables, establish their equations, choose the correct method, compute, and execute. That was student time devoted to the task. So if they struggled, which was the intent, they knew that it wouldn't last forever. We're going to be referring back to the strategy again for more clarity on the problem. So that was student time to task. For the data collection, it was a similar assessment to the pre-instruction assessment for the baseline data. In this case, it was 4 problems, graded the same way using the same rubric as the pre-assessment instruction. The 4 standards were the exact same, so the establishment of the equations and variables, the appropriate method, computation, and finally the solution. This is our rubric. Each score, each standard received a score from 0 to 3. 0, no answer, obviously, or some kind of strange gibberish, which middle school students sometimes give. Score of 1, they may have had the establishment of the 1 variable, and so on and so forth. So this rubric clearly outlines what score they got. So each student received a score of 4 numbers per problem. And it may look like 3, 3, 2, 1, which tells me they got 3s on the first standard and the second standard, 1 and 2. A 2 on the third standard. Too many buttons up here. And then a 1 on the last standard. They did not get the correct solution to the problem, but they were closer in the ballpark. So let's talk about the data analysis, the raw data comparison, if you will, between the control and the intervention groups. The application of an established rubric was essential for this. The points distributed with even weight among the standards, so one did not carry more weight than another. Well, I talked about a while ago with the diminishing return through the progression of standards. So you can't have 4 without 3, you can't have 3 without 2. And the existence of deltas among standards within averages. Now, as you can kind of see here, there is similar numbers across the board. For, let's take standard 1 for example. The baseline score for the intervention group, 2.62. the baseline score for the control group, 2.42. This comes into play later on. That's a 0.2 difference as far as the raw score between the intervention and control group. The post-intervention score, or post-control score, 2.71 to 2.86. Slightly higher, but you may see there's more gain from the control than the intervention, which is interesting, but we'll see what this really means as we dive further into this. A better representation of this in bar graph format, and we can really see that diminishing return right here. So we have here on standard 1, intervention, baseline, intervention, post-assessment. Control baseline, control post-assessment. If you look at just this bar right here, you would think, Mr. Watts, your idea is just plumb crazy and stupid. The kids who you just did the direct instruction with have outperformed your intervention students. But as I alluded to a while ago, with that diminishing return, and also with the understanding that the standards increase in metacognition as they go down the line. Yes, they can look at the problem and pull out the correct variables and probably assign the correct coefficients as well. That is essentially rote memorization and understanding. That's lower on the Bloom's taxonomy. As you go down the line with the standards, though, they all go down as far as the increase. But look at the trend that takes place with the control group. Standard 1, they're outperforming. Standard 2, it's almost even. Standard 3, they've actually lost while the intervention has gained. Standard 4, the control has lost while the intervention has gained. And if you look at the average of all the standards overall, the intervention has made gains, control, a slight loss. Well, let's think in terms of percent increase or percent decrease. We can see there is a higher percent increase for the control group on standard 1, as I said just a while ago on the bar graph. That is due to a higher baseline for the intervention group. I don't know, those students may have eaten breakfast that morning. They may pay more attention in class. I don't know. Those anomalies just take effect. The increased metacognition, though, throughout the progression of standards is what is most important throughout this entire concept. If you look at the comparison of the actual percent numbers over here, starting with standard 3 and going into 4, we see a negative sign in front of the control group. The intervention group made a consistent progression in each standard, which is strange, especially considering that after the first standard, the control group outperformed the intervention group. And so in visual representation, we can see that the control group had a decline in their performance from the baseline to the post-instructional assessment. And you can argue that the post-instructional assessment was harder than the pre-instructional baseline because it was problem-based and inquiry-based. But comparing that to the fact that the intervention students did not receive any direct instruction on how to solve a problem or how to solve that particular problem, they're giving a generic problem-solving strategy to be applied to each and every problem. They took this and they ran away with it. So here's the summary of that results, or of those results. The comparable baseline data between the control and the intervention group with exceptions. So lower baseline for the control gave an opportunity for a higher gain on the post-instructional assessment. The increased metacognition through the progression of standards is very important for all of this. Also, that diminishing return throughout raw scores for intervention and control groups. We also have the delta comparisons between the intervention and the control, so with the percent increase compared to the percent decrease. And our sustained levels of increase compared to inconsistent improvement and those subsequent losses for the control group. Now it's our turn to talk for a bit and discuss the next steps for the research question number 1. Rebecca.
Well, from what I see, you have a lot of good evidence that kids who are given a problem-solving approach to attacking any problem have good skills. And the kids who were given just a sort of rote kind of, this is how you solve the problem, didn't really do as well. But my question is, do you have any sort of studies or research that you've done that has some sort of lateral applicability?
Okay, so in terms of lateral applicability, what we can look at there is not just systems of equations. That was kind of the starting point because that's where the curriculum map failed for this time of the year.
Gotcha.
So the next step for that question would be, what other units of study, what other concepts would this apply to? Would it apply to proportionality? Would it apply to
I would like to see
probability?
you do, like in my school, kids break down with fractions. Like that's something that's very difficult for them. So I would like to see this backed up into like 4th or 5th grade and study to see if this sort of problem-solving approach to a problem would work when they start to understand how to break down a whole, you know?
Yes.
Because that's really challenging for younger
I agree. And
students.
for the sake of brevity, we will do that. Any other questions on the next steps?
Yes, can you tell me about
Dr.
any
Bowman.
benefits of cross-curricular applicability?
Okay, so that's one of the things I'm totally not sure about. And I can probably say that the related core content, such as the sciences, it may have an applicability there. So we looked at problem-based and inquiry-based instruction and how that would apply. When it comes to things like literacy, reading comprehension, I'm not totally sure that productive struggle is what we want out of students who are struggling to read anyway. It seems it may be counterintuitive, but until the study is done, we don't know what its effects would be. But in terms of science, or even solving things in relation to social studies content, it may make sense to try.
How about exceptional learners, gifted and talented, or advanced math versus your basic math?
Yes, what I do believe is that one of the things that this would really benefit are students who need some type of enrichment to take their learning beyond the next step. So this is probably the base, the start point to independent learning or independent study to find or target those students who may be able to go beyond facilitator-led instruction. And we know they're going to struggle with the content, but can they take that struggle on their own, move past that, and go beyond and then do great things with it? Anything else in the next steps? Nicole?
Are there any opportunities for professional development regarding this program?
I would say at this current time, because the system is so new in its infancy stages, that we'll start to see this take some momentum moving forward. And after some more studies are done, I would say that we could expect to see something in the realm of part of the teacher induction programs to use in their curriculum classes or their methods classes at the universities. For professional development, I mean, other than the 35, 40 minutes reading right here, this is probably about it. So, is that anything else on the next steps? All right, we'll move on, and this is basically the reflection of research question number 1. And I kind of use this this overused phrase, teaching a man to fish versus getting a man a fish. So we understand that with that concept, we're feeding a man for life by teaching him how to fish. So by teaching students a strategy to solve problems in a generic sense, allows them to take on problems, no matter what they are, and move beyond just the rote memorization. If I teach a student to work through one particular problem, that student now knows how to solve that problem, and that's it. Unless they can use generalization themselves, which is also a form of metacognition, to move beyond that problem and apply it elsewhere, oftentimes they get stuck on it. And we've all seen it. The problem on the test may have 2 or 3 things changed what they saw in class, and they just freak the heck out, and that's just the way it is. Also, the alliance with college and career-ready education. This is causing students to think on their own. We have to understand that when students go beyond the baccalaureate classroom, they're going out to a college world that does not really coddle them as much as they do in our formative years. So, by struggling now and understanding that they have to study on their own to really think and apply what they've learned to solve problems, it'll prepare them for college and also those high-tech careers that are so demanding. The professional abilities of educators is important. So, like I said, for an educator to be a facilitator and not an instructor is what we're trying to go towards. And the difficult implementation of instructional policies against student achievement and intellectual growth. This is not easy to do, bottom line. These are the references for the literature review. If you have some free time on your hands, I encourage you to check these out. And let's move straight into part 2. Everybody good? This should go fairly quickly. All right, so the survey that you all filled out for me, this is what this part of the presentation is all about. This is the PLC focus question, and what are the effects of Organizational trust. And why trust? I think it was Lou Holtz that's famous for saying, without trust, you have nothing. You can't be a leader without trust. So professional learning in communities and their members' perceptions on team cohesion. So just think back just a few weeks ago with those surveys you filled out for me, and we'll assess the data from that. The sampling participants, it was all of you all. So there's 7 representatives on our team, the 2 grade level teachers each. And of course we have our special ed representative, and I serve as a member of the PLC as well as the researcher. And we're all veteran teachers. The methodology for this, the instruments and materials, the Trust on Our Team survey. 1 page, 16 questions. Dual response. So each prompt had 2 applicable responses. And that was the level of agreement and the level of importance as rated by you, the survey taker. This was anonymous. In order to assess trust, you had to be anonymous and speak candidly. And then 6 members actually returned the surveys. And I won't point out any names who didn't have theirs in. This is the survey we took. This is a sampling of items 1 through 8 and 9 through 16. So an email was sent with the survey attachment. Each member received that email, asked for 5 days for a response. The survey was voluntary, you don't have to fill it out. It was also guaranteed to be anonymous. All responses were returned via email and 6 responses were received. All 16 items offered the identical response, so you could not delineate from that with the level of agreement or the level of importance as rated by you. All items addressed personal thoughts and feelings on 4 distinct categories. So there were 16 items in the shotgun blast. I broke those down and categorized them in 4 ways. 2 were, think of this way, internal, and then 2 were external. So it was the trust in the abilities of your colleagues, what they can do as far as good teachers and good educators. The perception of your colleagues' trust in you to do your job well. The trust in your colleagues' support of the PLC, and then your perception of your colleagues' trust in your personal support of the PLC. There was an open response opportunity, but no data was collected on that question or that prompt. Let's move into the data analysis. I have a total of 8 pie charts to compare here. And the first one, the trust in the abilities of colleagues. So as we can see, it's blatantly obvious that we mostly agree that we can trust our colleagues and how well they do their job. It's also interesting to see the level of importance and how we rate that as important. I think it did win out 45%, very important. The other 2 equally distributed, 33 and 27%. The perception of colleagues' trust and personal abilities, we're still in high agreement on that, so
We're talking.
I know.
It's very interesting results.
It is. So high agreement once again on the perception of colleagues' trust and personal abilities. And this time it's kind of interesting to see the level of importance that we've assigned this topic based on the trust in our colleagues themselves. Look at the size of the not important. I don't care what people think about me, but I do care what I think about them. Or should I reverse that? That may be mistake number 1 in this whole presentation. I care what they think about me, but I don't care what I think about them. So the trust and colleague support of the PLC, we have a comparable relationship between agreement and importance at higher emphasis. Same distribution almost between all these. The perception of colleagues' trust and personal support of the PLC. So how well your colleagues think we're doing our own support of the PLC. Similar levels of agreement, but substantially less importance. Now what all this means, we can look through those 8 pie charts and we can pull out the strengths based on trust for our PLC. So the majority of PLC members, which is all of us right here in this room, our perceptions on the culture of trust is mostly positive. Also, the PLC members place high importance on the trustworthiness of their colleagues. And most PLC members foster a sense of comfort and cohesiveness within their PLC. And this does 3 things for us. That last bullet is very important because it encourages open sharing. We can share our thoughts and our ideas. Our $5 word shows back up facilitates. We have quality peer review and feedback. So I trust you to watch my instruction and tell me the things that I'm doing well or things that I should improve upon. And also allows for growth as individuals and communities. We cannot grow as a PLC if we're always thinking that somebody else is out to get us, especially a member of our own team. However, there is a downside to this, and we have the weaknesses in the results. There was some percentage of disagreement among all categories. It's not just one or two here and there, it was all categories, all four, that lead to concern that issues of trust exist on some levels. This may be caused by personal experience, may be caused by just perception. And also, the PLC members may value trustworthiness of others more so than trustworthiness of themselves, which is indicative of a volatile culture. If you think about it in this term, it's that I can do no wrong, and I don't care what you think about how I do it. But I think there's more importance on the fact that what you do should outweigh anything that I do, or your thoughts thereof. So it's the perception about how well we can trust each other and how well others can trust us. Which takes us in the next steps to address weaknesses. Now in this case right here, I've kind of started the ball a little bit to kind of facilitate this conversation. And the first of those next steps,
Are we addressing weaknesses in the PLC or the instruction?
weaknesses in the PLC.
Oh, okay.
Yeah.
Thank you.
Yes, ma'am.
This is a very good presentation.
Well, thank you, Rebecca. I do appreciate that. There's more pizza for you on the table. What we do is we encourage collegial planning with the PLC. And what I mean by that is that grade level plans, grade level pairs for common assessment writing. Also, the vertical alignment for standards-based curriculum development. So we have two options there to work with. The vertical alignment is essential because we have 6th, 7th, and 8th grade represented on this team or this department. And how we align that curriculum is essential to how our students achieve throughout the entire process. And what that does in terms of trust is that it allows us to work together to see what our counterparts at levels lower and levels higher are doing. We can look at their instruction. We can give them the feedback on how our instruction is used and implemented to take those things they learned prior or later on and keep them aligned vertically. And that does not happen without trust in each other as a department. The next thing to talk about is the collaborative planning with special educators. So we have a special education representative in this math department. And the perception is sometimes that they're left out in the dark on certain things. They're only included in the discussion about math curriculum. And the reason that is because we went through our mathematical training in college as our teacher induction program, and we just feel that we are the content experts. But we have a lot to gain from people that are not the same as us. And you can't really be a contributing member of the team unless you are trusted. And so our special educators we need to realize they bring a lot to the table. They have the expertise that fills the gaps in areas that we may not be good at, and we do the same for them, vice versa. And that's how teamwork and cohesion is supposed to go. And lastly, opportunities for PLC observational classrooms. So one of the things that stood out on that survey was how we don't really feel comfortable with other teachers observing our classrooms and then providing feedback, because sometimes the perception is there an ulterior motive to what they're observing and trying to write down? Are they going to report this to the principal for how bad of a job I'm doing? Or are they here for the right reason, to support and build me, and do I do the same for them? So these are the reflections on the PLC survey and where we go from here. I will say that our department has a solid foundation of trust. We have a personal tendency to place the trust of others as more important than the trust in us ourselves. And keep in mind that trust is a two-way street, or a swinging door, if you will. You can't expect trust in yourself without offering trust to others. Where we go from here, are we establishing initial trust, or are we fighting the uphill battle to regain trust? So the hard question, has something happened through personal experience to cause us to disagree on some levels with that trust survey? Or is it one of those things to where I don't know these people well enough to allow them into my little bubble where I feel safe and comfortable? And that's where trust has to begin. So there's two things there, initial trust versus regaining trust. And then student achievement is at the forefront. We must have trust in the PLC to ensure we have a chance to accomplish any goals. And ladies and gentlemen, that concludes my presentation. Thank you for your time. James, you hit the camera.